Well, hello and welcome. It is time once again to try to fix something. Today on the workbench, we're taking a look at a power supply from a PS5. Particularly, it's an ADP-400FR. Now, this was sent in by a viewer of the channel named Art. And we're going to take a look at it and see if we can get this running again. You can see the screws are missing, so it's been opened up before. So I'm not sure what's been done to it. But let's see if we can make it output some 12 volts once again. There we are. Yeah, I do see where something has gone splat in that cover, it looks like. See it right in there. And what does that line up with? Yeah, right over here I do see a little arc spot there too. I do indeed, right in here. Not sure how well that shows you. Yeah, you can see a dark area right in there. A little bit of charred remains of something. Go ahead and get this out of the case. We'll get these covers out of the way. So, just to be safe, let's go ahead and try to discharge this thing. Nope, no voltage. None whatsoever. Okay. So yeah, I can kind of see where the burn mark is there. That's the only spot I see though. Okay. Let's just check a few things. See if I can get a meter in the shot here. May have to zoom out some with my camera. Continuity mode. Let's just check our fuse for the heck of it, which is right over here. Fuse good. I'm assuming we don't have a short across the these large filter caps. No, no short there. All right, if I can get this, is our fusible resistor blown right here, which is a 0.1, I believe. It is blown. If that's blown, then our MOSFETs are most likely blown. That one's not. Okay, yeah, she's shorted. Yeah, I was just checking to gate. Oh, that one seems to be shorted over to the gate. So, open resistor, bad MOSFETs. I wonder if our DAP53 has survived right here. We can go over it right quick like, but I mean, with some shorted MOSFETs attached to it, it's hard to get, you know, good readings on every pin when it's, you know, at least two of those pins are connected to some shorted MOSFETs. Red probe on the common ground. Here's pin 1. Looks good. Pin 2 looks good. 3. 4 I think is grounded. 5, 6 looks a little low. Let's keep that in mind. I think 6, yeah, 6 now that I look at it here is one of the MOSFET drive. You know, it goes to the gate of the MOSFET, so that's probably normal with a shorted MOSFET. And then 7 is, I think, no connection, isn't it? Yeah. 8, 1.5. 9 is definitely low. I think that's maybe the other gate, but it's definitely low. 10 is also low. 11 maybe grounded, I can't remember. Need to look at my notes, I guess. 12 is no connection. 13, 14, 15, 16. Let's go back over here. Didn't we have, was it pin 4 was shorted to ground? Is that normal? Let me find my notes. Where'd I put them? Where'd I put them? Nope, that's not them. I've got 2 or 3 little notepads floating around here, but I never have the one I need at the appropriate time. Just a moment, let me find my notes. Well, I was unable to find my notepad of notes, but I do have a picture of that notepad. So at least I'll always have that. And I can confirm pin 4 is grounded, so that's normal. So we do have problems though on the drive pins going to the MOSFETs, but that's to be expected. Let's get those MOSFETs out and see if our diode readings then kind of go somewhat normal. Because I have a feeling both these MOSFETs have died. It seems to happen quite a bit. But then they work pretty hard, and if something comes along that makes them turn on, a solid 100%, then it's a problem. I do have a solder sucker, but it's over here, not plugged in right now. And I'm almost as fast just with some solder wick. I hear there's a thunderstorm going on outside, so you may hear some of that going on. Oops. Finally, get out of there. Okay, with our shorted MOSFETs out, there we go again. With our shorted MOSFETs out, what kind of readings are we getting? Let me see if I can get the meter in the shot here. let's see. All right, pin 1, 2, 3, 4 is ground. That's normal. 5, 6, 7 is Shouldn't I have a reading on 7? Nope, no reading on 7. 8 looks normal now. 1.49. 9. I don't remember. Well, 9 would have a reading if the gate of that MOSFET was there. So maybe that's normal now. 10, 11, 12, no connection. 13, 14, 15, 16. Okay, so we still have a couple of questionable readings there, but then again, we don't have any MOSFETs in there. So that's probably to be expected. Again, let's put a couple of MOSFETs in there. And we got to remember to replace that resistor there. It is coming quite the storm outside. Let me go ahead and remove this resistor. Maybe a quick cleanup. All right. Now that our MOSFETs have been changed, has that changed our readings? I'm sure it has. Let's see. 1, 2, 3, 4 is ground. 5, 6, 7 is open. Yep. 8, 1.49. That looks completely fine. Number 9 is 1.12. This is close to that. 10, yeah, 1.15. There we go. That looks normal. And then 11. Is 11 low? Let me look. Nope. My notes say 521, so 9, 10, 11, 12, I think is no connection. 13, 14, 15, 16. That, yeah, DAP53 looks pretty good there. As long as maybe we didn't lose anything else. I'm gonna try to clean up this little arc spot over here by these large resistors. Little carbon track there. Probably doesn't need to be there. Okay, I think we're about ready to test. Let's hope this DMP-014 isn't damaged, because I still have not found a source for those. It's what they call like a secondary side regulator or controller. It's on the cold side, the secondary side of the transformer, and it handles, you know, a lot of the regulation, the feedback. Like normally there'd be a precision reference, and there'd be, you know, a lot of things, you know, around that. Well, all that is built into that chip now, because you don't see any of the other extraneous circuitry. So they built a lot of stuff into that, and I cannot find that chip. DNP-014. All right, let's see if I can get some of this alcohol, dry it off. If I can get my load turned on. Negative and positive. And let me get some leads connected. I do like to watch the voltage across these you know, boost filter capacitors right here. Can kind of tell you a lot to see what that's doing. So this way I can do it, still be hands-free. Now, get this positioned. Where is my, here's my power cord. It's not turned on right now. It's switched off to the side. And let's see. Maybe we'll use this other meter. Yep, not much way to get it in the shot, is there? Maybe, maybe. There. So I'm gonna use my variable AC isolated power supply over here. Turn it way down. We're gonna bring it up slow. You can already see it starting to rectify the voltage, but it's very, very little voltage coming in. It's probably gonna have to get to like 60, 70 volts DC there at least before you see it trying to start. Bringing up the AC. She should have tried to start by now. No, there it goes. I was wrong. Well, I got my leads reversed on the power supply here, but We are not putting out negative voltage. There we go. Started a little bit later than I remembered him starting. Okay. That seems a little low. I'm used to this being right about 395. So we have to look into that. I mean, it's running. You know, there's no load on it. That's going to be, let me put a load on it and I'll bet you you'll see this changed. Oh, that's it. Load on. All right, 7 amp load, 390 volts. That's a little bit better. 11.95 volts. I think we are working. I'm still, my voltage going in is a little low. Bring it up to about 120. Yeah. When I brought my AC voltage on into 120 volts, brought that on up. Now we're running about 395. Which that's where I'm used to seeing, about 395. And this is a 7 amp load. Okay. Let me see if I can get you a better angle of this. Okay, how's that? You can see that. You can see the load over there. Drawing 7 amps constant current, 83 watts. Voltage is a little bit lower over there, of course, because of the drop across these leads. Although they're short leads and they're a pretty good size, you still get a slight drop. Dropping from 11.95 to 11.88. I'll take it. But yeah, that looks good. Let me put all this back together. But it looks good. All right, well, since that one is completed, I was just cleaning it a little bit. This one's going to be fine, I believe. It's ready to go. So, since that one went pretty quick, I think we're going to look at one more for art. We have another one, a second dead ADP-400FR. So I put this one to the side. And let's just see what we can do with this one, shall we? Okay, our second contestant, this definitely got roaches all in it, and you can see them. Okay, and they're all around that DAP-53. That's the area they're in. Let me, I have not discharged this yet. Let me do that before I handle it too much. Just in case. I think it's probably pretty dead because it's been dead for a while, I think. Where are those capacitors? Yeah, right down here. Anything? No. No. Rather dead. Okay. Let me put this over the garbage can a second, and then maybe brush off a little bit of, and there's some in the case there, aren't there? All rather dead, thankfully. So we've got some scorch marks in that area where they have stepped on some stuff. I don't want to clean that up yet because I kind of like to know where that is. Unless there's an obvious, you know, short or a charred area, you know, carbon buildup. Just leave it there for right now while we make a few checks. friend continuity mode. I just poked myself with the probe. That's kind of sharp. Ouch. All right, fuse. Fuse is way over here. Yeah, fuse is way over here. Oh, we have a dead fuse. We do have a dead fuse. Okay, main fuse is blown. What about our fusible resistor? It's still good, which probably means our MOSFETs are still good. Because if they had shorted, they would have taken that resistor out with them, just like on that last supply. Okay. So, what did we get? A couple of, there's a transistor and a diode down in there. Let's just see, and that's exactly where all this nastiness is right on top of those components. And we have a short there. We do indeed. All right, this is a diode over to this side, and that seems to be okay. But this transistor there, which I have a feeling is probably the PFC transistor, is gone. And I don't know that I have any of these, because I've never had to replace one. Or have I? I can't remember now. Well, let's get this transistor out right here. This one's actually screwed to the heatsink, so I'll have to undo that. Just see. Yep, rather short. Every which way you go. Okay. So I'm wondering if that also got our DAP53, since it drives that power factor corrector. Let's just go to diode mode. Pin 1, 2, 3, 4 is ground, 5 is good, 6, 7 is no connection, 8 is a little, that's on the high side, should be like 1.5. Of course, that may be because of a transistor being removed. That's a little bit off. 10, that's all right. 11, 12 is nothing. 13, 14, 15, 16. Let me look to see which pin of this IC drives the PFC. It looks like pin 5 is the gate of the PFC. Pin 5. That's not shorted. She's not shorted. Pin 8 is the drain of the PFC, I think. Okay, well, the transistor's out, so could be good. That looks normal now. Yeah. 12, 13, 14, 15, 16. Really, it doesn't look totally out of line. We know we blew the fuse. I wonder if we damaged the bridge rectifier. Probably not. Those things are rather tough. Rather tough. Yeah, I think our bridge is fine. Okay. Now maybe I'll give it a little bit of cleaning. So, this transistor is a 40N60M2. 40N60M2. Let's see if I have something appropriate from my maybe from my supply of parts for the PS4. The PS4 supplies anyway. Well, after looking through my part stash, I did find a 42N60M2, which seems to be almost the exact same part, or the exact same part. They're both 34 amp, 650 volt MOSFETs, so I have one of those on hand, so let's see if we can get that installed. I need to move these ferrite beads over, if I can get that to focus. Move those ferrite beads over, and that'll probably fix it. Probably. May have gotten something else, we'll find out though. Well, our PFC drive MOSFET has been changed out and our fuse has been replaced. I think we're ready to test. Once again, I'm monitoring the voltage across these filter caps right here, and I'm going to be monitoring the output voltage. I do have my load connected, but I'm going to put this meter right here. I'm going to dial down the AC input voltage, and we're going to bring it up nice and slow and see what happens. Any second. It started up, and we are running. Bring this on up to 120 volts AC in, and that looks normal. It should be around 395 here and 11.94 on the output. That's excellent. Okay, let this run a little bit. I've got the load on it, and I'll turn a fan on it over here, let a little airflow across it, and make sure it stays going, but I'm pretty sure we're in good shape. Excellent. Well, that's two ADP-400FRs repaired. We were very lucky. They were reasonably simple repairs. We didn't have a damaged DNP-014. And if anyone out there knows where I can get a DNP-014, please let me know down in the comments, because I have not been able to find them. I hope you thought that was somewhat interesting, educational, entertaining, or any of the above. If you did, please give me a thumbs up. And I will see you in that very next repair. So long for now.